Hello, we're Team Tekon 16277, and this is our Tekon Talk, Introduction to Roadrunner. Agenda. This is the topics that we'll be covering today. What is Roadrunner? Benefits of Roadrunner, how Roadrunner works, some vocabulary, tuning for your robot, and finally, a summary.
What is Roadrunner? So Roadrunner is a motion profile library that can be used in both auto and teleop. It uses coordinate geometry to get from one place in the field to another, and you can use it to control the velocity and acceleration of your robot.
Benefits of Roadrunner. Roadrunner improves robot consistency and accuracy on the field. It automatically calculates the velocity and the acceleration, and it allows for complex path following when your robot's on the field.
So here's some vocabulary terms in Roadrunner. So localization is the ability for your robot to know where it is located at all times. Motion profiling is basically graphing of the behavior that something must follow to reach a certain destination or state. Open loop control is estimating the values you need until you get a value that satisfies your needs. Closed loop control gives more accurate control over the speed, distance using encoders.
Next, we have vector 2D. Vector 2D represents a 2D vector using XY coordinates. Pose 2D represents a 2D robot pose using XY coordinates and a heading. Trajectories maps what your robot's velocity should be along with its route. Spline path is the path that retains a smooth transition into other movements.
This is how Roadrunner works. The first thing the robot does is that it uses localization to find where it is on the field. Then it uses trajectory sequences to plot a route to get from one point to another. Finally, it uses algorithms that we give it so that way it gets from one point to another smoothly without any interruptions.
These are the specific steps of tuning robot to ensure accuracy when you're using Roadrunner. The items that are starred in red only apply when you're using dead wheels. The first step to tuning your robot is checking your drive constants. Below is a link to the learnroadrunner.com drive constant steps. You would want to first click Configure Me. Next, you would want to pick the certain chassis that you're using. In our case, we chose I'm using my own. You would also have to choose what type of motor you're using. In our case, it would be GoBuilda 5202 series, as shown on the right. Along with choosing your motor, you would have to choose the RPM for the specific motor. In our case, we chose the 312 RPM. You would then have to enter the gear ratio, as shown on the right. In our case, it's 1:1, so make sure you enter the gear ratio for your chassis. You would then have to choose your wheel radius. In our case, it's the 96mm mechanism wheel. And you would also have to put in your estimated track width distance. Track width is the distance between the two wheels. And in our case, the track width would be 15 inches. Finally, you would have to choose yes or no depending on whether or not you're using encoders. In our case, we chose yes. As shown, the drive constants file should be then generated after all of these steps. These are some examples of the drive constants put into your Roadrunner code.
So you need to continue with the rest of the steps such as drive, feed forward tuner, straight test, or etc., which is described in the documentation. So if the robot doesn't travel far enough in the straight test or doesn't strafe or turn far enough, you can adjust the following values in the drive constants. You can either change the track width or the max angle velocity. Sample mechanism drive tunings. Inertial measurement units are sensors in the rev hub that can detect your angle on the robot. You need to clarify if it's on the x-axis, the y-axis, or the z-axis. Lateral multipliers are variables that you can change to ensure that you are strafing far enough. The set value will be 1, but in our case, we had to use 2.2. Once your robot tuning is complete, and this might take a while, so you don't need to worry, you need to create a mechanism drive.java file. So you need to copy the sample mechanism drive.java code into the team code folder and rename it to whatever you want. For example, we are using Tekon mechanism drive, and this class will be instantiated in your autonomous Java code.
This is a quick summary of everything that we've talked about. Roadrunner is a motion profiling library that uses coordinate geometry to get from one point to another on the field.
Roadrunner is beneficial for accuracy when your robot is running.
Roadrunner also allows for complex path following when your robot is running on the field.
And it is okay to not get 100% accurate results every single time. Just keep on trying until you find the right values. Thank you for watching.